So here we have a problem that says to use an algebraic approach to solve the following equation on the specified domain. So there's multiple ways that we could solve this problem. They do say to use an algebraic approach. So I'm going to start in that method, but we're also going to explore some other possible methods. So let's start with our cosecant x plus 2 is equal to 0. To solve this algebraically, let's first solve for the trig function. So I'm going to move the plus 2 to the other side by subtracting 2 on both sides. So that gives that cosecant x is equal to negative 2. Since cosecant is the reciprocal of sine, we can go ahead and write cosecant as, we can either write this as 1 over sine is equal to negative 2, or we can write it as sine is equal to negative 1 over 2, because, so there's two different ways that we could do this. If we see the negative 2 as being over 1, we can flip this side and write it as sine of x is equal to negative 1 over 2. So I think that's the easier way. We could write this as 1 over sine is equal to negative 2, but then we have to do some more solving. So I think this strategy is more simple. So what we're doing is we're looking for where is sine equal to negative 1/2. I think the easiest way of doing this is by using the unit circle. So whether you have to memorize the unit circle or you have it as a reference in your class, you can write your unit circle if you don't have it available. But just looking at this unit circle, let's see how we might be able to find that. Keep in mind that sine is the y coordinate, if I could spell. Y coordinate on the unit circle is the sine. So we're looking for where the y coordinate is equal to negative 1/2. So that happens right here, where the angle is equal to, because these are in radians, I'll write the radian answer is 7 pi over 6. Or it happens again here at 11 pi over 6. So these are the two angles on the unit circle itself. But since it asks us to find the answer over the domain from 2 pi to 6 pi, neither of these two answers are within that domain because these are both less than 2 pi. So we would need to take these answers and add 2 pi to them to make the next coterminal angle going all the way around the unit circle again. So if we take 7 pi over 6 and we add 2 pi to it to find the next circle around, that would be the same thing as 7 pi over 6 plus, to write 2 pi over with a denominator of 6, we need to multiply top and bottom by 6. So that would be 12 pi over 6, which is equal to 19 pi over 6. So since that is adding 2 pi, that would be between 2 pi and 4 pi, because that would be on the second rotation. And we can do the same thing, that would be between 2 pi and 4 pi, because it would be the second rotation. But we also want to find the answer between 4 pi and 6 pi, and that would be going around the circle once more. So 19 pi over 6 would be one answer, but then if we add 12 pi over 6 a second time, that would give us 31 pi over 6. Would be coterminal with 7 pi over 6, but is the second time around. So that would make it between 4 pi and 6 pi. We can do the same thing with this 11 pi over 6 answer and add add 2 pi to it once to get the answer between 2 pi and 4 pi, and then add 2 pi to it a second time to get it between 4 pi and 6 pi. So to do that, let me just come up here where I have a little bit more room, is 11 pi over 6. I need to add 2 pi. So that's the same thing as 11 pi over 6 plus 12 pi over 6, which is 23 pi over 6. That would be the answer, the coterminal angle of 11 pi over 6 between 2 pi and 4 pi. And then if we add 2 pi a second time, 23 pi over 6 plus 12 pi over 6 would be 35 pi over 6. So that would be where we would stop, because if we add 2 pi another time, that would be between 6 pi and 8 pi. We have to stop at 6 pi. So these would be our 4 solutions using the unit circle. If we are, or let me say this, I have a student who said that they are allowed to use Desmos on this type of problem. So if you are allowed to use Desmos on a problem like this, you can just take the two sides of the equation, the cosecant x plus 2, make that like a y1, and then 0 would be a y2. So for example, if we switch here to Desmos, we can make y is equal to, let's see, on Desmos, not only do you have the options of sine, cos, and tan, you also have the trig functions of cosecant, secant, and cotangent. So while most calculators you can't plug in secant, or it's not as easy because they don't have them listed as a trig function, you can just choose cosecant in Desmos. So you can do cosecant x plus 2 as y1, or your first y, and then you can make your second equal to, like, y is equal to 0. So we're wanting to find out where these two intersect and where they do between 2 pi and 6 pi. So let me move this over. And by the way, I do have this in in radians and not in degrees. So you will need to do it that way if you want your answer in radians. And 2 pi, keep in mind that since pi is equal to 3.14 approximately, 2 pi is going to equal 6.28 approximately. So we are looking to the right of 2 pi, which will start here. So we just barely missed this solution, which we found before on the unit circle was 11 pi over 6. And I just clicked on the graph there to be able to pull that up. So if we look for the next solution, there's our 19 pi over 6 option. Then the one after that is 23 pi over 6. The next one here is 31 pi over 6. And then we have the 35 pi over 6, the ones that we found on the unit circle. So if you do want to verify that these are going to be between 2 pi and 6 pi, keep in mind that you can just put here 2 pi, and that gives you 6.28. So that'll be your decimal of the smallest answer that you're looking for. And then we can also put 6 pi, and that gives us 18.84. So once we find a solution that's larger than 18.84, we definitely know that we need to stop. So if we look for this next solution here, 43 pi over 6, if we plug that in, 43 pi over 6, that's 22.5. So that's too large. It's outside of our domain. So if you wanted to use Desmos, you could also use a solution such as this one. And Desmos is really convenient how that they even give it to you in a fraction in terms of pi, which most calculators don't do that. Okay, so if you have any questions, feel free to ask those questions in the comments and I'll do my best at getting back to you. Also, if this video was helpful for you, please like the video and share with anybody who might be in your class or somebody who you think might benefit from this video as well to help spread the word. And yeah, thanks for watching and happy studies.